All right, now in section 8.3, we're talking about a population proportion. There are two types of statistical inferences. We're going to look at estimation and hypothesis testing. Chapter 8 is all about estimation, and Chapter 9 is all about hypothesis testing. But in both those chapters, the only two parameters that we're going to look at is the mean and proportion. Okay, so some definition that you will need for Chapter 8, a point estimate is a single value or a point used to estimate a population parameter. So when we're trying to find proportion, then the sample proportion, which is p hat, right here, that is the best point to use to estimate the population parameter p. That's going to be important here in a minute. Now, this confidence interval, that's what we're going to find. It's going to be a range of values used to estimate the true value of the population parameter. So you'll have a range of values, and hopefully the true value of the population parameter, or proportion in this case, is somewhere within that range. And then to be how confident you are in that value being in that range, we call a confidence level. The probability that the confidence interval actually does contain the population parameter. The three most common levels are 90, 95, and 99. Okay, and then we're going to have critical values, and it's a number on the borderline separating the sample statistics that are likely to occur from those that are unlikely to occur. Okay, now we've got notations here. This is a z-score alpha sub 2. It's really just a z-score. And then alpha is equal to 1 minus the confidence level. So we'll get back to those, or we'll come back to those here in a second. Now your confidence level, that is always going to go in the middle of the normal distribution. It's always in the middle, like it is right here. Okay. Now we could say that your confidence level plus alpha is equal to 1. Okay, so if I've got this side over here and this side over here, if I got two sides, then I need to break this alpha into two parts. So alpha over 2, alpha over 2. Now when I add those back, half of alpha plus half of alpha, that gives me 1 alpha, or just alpha. Okay? So you're always going to have this set up right here. The confidence level will go in the middle, and then alpha over 2 on either side. Okay. What's important here is the definition of p hat, which is x over n, or we would say the number of successes over the total number of observations in your sample. Now this actually boils back down to when we're talking about binomial distributions, and that's actually said in here. Let x represent the number of successes out of a sample of n observations. If each observation is a success with a probability p, independent of the other observations, then x is a binomial random variable with parameters p and n. But really what you need to know is this part right here. P hat is equal to x over n. Okay. This table will be given to you the day of the test, and let me go ahead and show you how you would actually derive this formula, or this table. So here we're saying how to derive that chart for a 90% confidence level. So it says for a 90% confidence level, 90%, we have an alpha level of 0.10 and a critical value, which is really just a z-score, of 1.645. Now let me show you how they get that. Okay, so they gave us a confidence level of 90%. Remember that confidence level is going to go in the middle. And I'm going to change it from 90% to 0.90. Okay, to get alpha, alpha is 1 minus your confidence level. So that's going to be 1 minus 0.90, or the same thing as 0.10. Well, there's the first thing that the chart gives us. Alpha is 0.10. Okay, so on either side, we've got alpha over 2 and alpha over 2. So 0.10 over 2 on either side, 0.10 over 2. So that would give us 0.05 and 0.05. Okay, we are looking for a positive z-score. So we're looking for this z-score right here. Now remember, your z-score, it's always the area from that z-score to the left. So I need to pick up that 0.90 plus a 0.05. If I add those two, I get 0.95, which is the area to the left of my z-score. Now I need to go back to my z-score table. Okay, so between this number and this number, notice I've got a star right there. I'm going to follow that all the way down. If I've got an area of 0.95, my z-score will be 1.645. Okay, so this is equal to 1.645. Should go back to the chart. There's our answer, 1.645. And that's how they are deriving that table right there. So say I ask for a critical value with a confidence level that is not on this chart right here. Notice I got 80, but I don't have 81. So what I need to do is follow the steps that I just used in this example right here. So same thing, you're going to have 0.81 in the middle. Find your alpha, which is 1 minus 0.81, which is 0.19. To this side and to this side would be alpha over 2, or 0.19 over 2, which is the same thing as 0.095. Same thing over here. 0.19 over 2, 0.095. I'm looking for the positive z-score, so this one right here, because this one over here is the negative z-score. Because remember, if your mean is right here, everything below it will be negative, everything above it will be positive. Okay, so starting here, going all the way over, I've got 0.81, and I need to add that to 0.095. When I add those two numbers, that gives me 0.905. That's the area I need to look in my chart and find to give me my z-score. Okay, so we were on the positive side, so I need to be on the positive side for z-scores. So somewhere in here, I've got 0.905. And there it is right there. That's as close as I'm going to get to it. 0.9049, that's as close as I'm going to get to 0.905. So that gives me 1.31 for my z-score. So this is equal to 1.31. And that's my answer right there. That's the critical value for a confidence level of 81, which is pretty close. If it was confidence level 80, their critical value was 1.28. If it's 81, then the critical value is 1.31. They're pretty close to each other. Okay. It says find the critical value that corresponds to alpha of 0.17. Okay, so I know that the critical value is, or not the critical value, the confidence level is going to go in the middle. Confidence level is 1 minus alpha, so 1 minus 0.17, that gives me 0.83. So 0.83, and then on either side, I know that's alpha over 2, or 0.17 over 2, which that is 0.085 on both sides. I'm looking for this z-score right here. So I need to pick up this 0.83 and 0.085, add them together because I need the area to the left of that z-score in order to go to my table and find that z-score. So I've got 0.085 plus 0.83. That gives me 0.915. So then I go back to my table, and somewhere here in the middle, not on the edges here, but somewhere in the middle, I need to find 0.915, which that would be, looks like the closest would be right here, 0.9147. That'd be the closest one. So that gives me a z-score of 1.37. So it's equal to 1.37. So that is my critical value for a alpha of 0.17 or a confidence level of 83%.